All right, today we're just going to do a quick review on naming and formula writing for the different types of compounds you're responsible for. So now we're putting everything together. So we got ionic compounds, covalent compounds, acids, and then we also have organic compounds. And remember, for organic compounds, it's only going to be hydrocarbons, and we're always going to assume they're straight chained, and we're always going to assume that if it's an alkene or an alkyne, then there's only one of the bonds. So if it's an alkene, there's only one double bond between carbon atoms. And if it's an alkyne, there's only one triple bond. So it's not going to be very complicated when it comes to the organic nomenclature. So I'm just going to take you through a practice test. Your test is coming up, so here's what you need to be able to do with just a periodic table. And don't forget, you also get a list of polyatomic ions. So you can have those out. You just got to know what to do with them. And again, that's all you get is a periodic table and a list, a reference guide for polyatomic ions. I'm going to go through this kind of quickly. I'm going to show you a practice test, and this is assuming that you kind of have a couple things down that I'm going to show you first, and then we're just going to go through a practice test together. All right. So this is assuming you kind of have this flow chart ready to go, right? You can identify if it's ionic, covalent, acid, and then we're going to throw in another category here, organic. So if it has carbon and hydrogen, you're going to classify that as organic. And these are the kind of different rules. Another thing you might want to reference to study is your nomenclature cheat sheet. So, you know, knowing when you have, when you need a Roman numeral in your name. These are the more common polyatomics, but again, you'll get a reference guide of all your polyatomics, your covalent prefixes, your acid naming rules, and your organic prefixes. And then these patterns for our hydrocarbons. Is it an alkane? Is it following this pattern? Is it an alkene? Is it following that formula, basically? And if it's an alkyne, it's following that formula. So this is, we're jumping into this test, or this practice test, with the assumption that you're familiar with all this stuff. If you're not, you got to go back and review. Okay. So let's look at this practice test. All right. So I mean, if you can do this with just a periodic table and a list of polyatomic ions, you're in great shape. If you can't, you need to study. All right. So the first thing we're going to do is just classify it: ionic, covalent, acid, or organic. Okay. And so I'm just going to go down the list here for part one. So we're given the formula and we got to name it. But the very first thing we got to do is classify: ionic, covalent, acid, organic. So remember, if you got H in front, acid. So let's just find that one. There we go. H in front. I know I'm going to call that an acid. Down here. If you have a metal or ammonium, you know it's ionic. So here's ammonium. So I know that's ionic. And here's a metal. So I know that's ionic. And here's another metal, so I know that's ionic. All right. And the rest are either going to be organic or covalent. So two nonmetals, covalent. Oops. Okay. Also two nonmetals, covalent. Two nonmetals, but hydrocarbon, so organic. Okay. So identifying is pretty easy, and that's how you do it. Just go, you know, it doesn't have to take a long time. So let's focus on the ionic ones first. So remember, ionic is just name the cation, name the anion. So if I want to name this, I got to know the name of the cation is, ammonium, and the name of that anion is sulfite. And remember, you would have your polyatomic reference guide. So you would have the name of NH4 plus, and you would have the name of SO3 2- on your chart. And all you have to do is put it together. All right. I'm going to go down here for this ionic compound because that's an easy one. Potassium is the name of the metal, and it's not a mom ion, so it doesn't need a Roman numeral. And then bromide. Okay. Br is not a polyatomic, so just bromide. Okay. Now this one's going to be a little bit more complicated. Why? Because iron is a mom ion, so we're going to need a Roman numeral. So it's iron, and I'm going to leave a space there for the Roman numeral. So I know it's iron carbonate, but the question is, what's the Roman numeral? And in this case, the Roman numeral is 3, so it's iron 3. Now, the way we know it's iron 3, and I really should just have one space between. So the reason I know it's iron 3 is, remember, that Roman numeral represents the charge of the iron. We always know the charge of carbonate, or the anion. And again, you have your polyatomic reference sheet. So you could look up CO3 on your reference sheet, see that it's a 2- charge, but we'd have to know that we have 3 of them based on the formula. So we have 3 of these ions, and they're 2- apiece. So that's a total of 6-. So to be neutral, the iron's total has to be 6+, but you have 2 of them. So that means each iron is 3+, so iron 3 carbonate, okay? So we've named our ionic compounds. Now let's go to our regular covalent compounds. And remember, we're just using our covalent prefixes, mono, di, tri, tetra, so on. So we got 2 phosphoruses, so we say diphosphorus. 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 And then 4 oxygens, tetra. But remember, we don't say tetraoxide. We don't have the A and the O right next to each other, so we say tetroxide. Okay? And we always change the ending of the second element to IDE for covalent compounds. So diphosphorus, 2 phosphoruses, and 4 oxygens, tetroxide. Okay? And then let's go to this one. We got 1 nitrogen. So remember, we're not going to say mono nitrogen. We're just going to say nitrogen. We only use mono for the second element if there's one, but not for the first element. So nitrogen, and then our prefix for 3 is tri, and fluoride. So nitrogen trifluoride for that one. Okay, so let's go to our acid. No oxygen. I'm going to immediately put the prefix hydro. And I'd have to recognize that CN is cyanide. And again, you have your polyatomic ion sheet, so you could look up cyanide. And we change it to hydro, cyanic. Ide goes to ic, and the word acid, so hydrocyanic acid. And then the last one here, organic. So now we got to use our organic prefixes. The organic prefixes tell you how many carbons you have. I got 3 carbons, so that's prop. Whoops, didn't mean to do that. Over here. So prop is 3 carbons. And then the question is it ene, or sorry, is it ane, or is it ene, or is it ine? And so remember, if the number of hydrogens is times 2 plus 2, the number of carbons, then it's ane. If it's just times 2, then it's ene. And if it's times 2 minus 2, it's ine. So we got 3 carbons, times 2 is 6. So this is following the model CXH2X, which means it's an alkene, so propene. All right. So let's go down to the next thing. All right, so the next thing is the opposite. So we're given the name, and we got to go to the formula. But again, the first thing we have to do is classify it as ionic, covalent, acid, organic. So acids are easy if the word acid is in there, so there we go. So I know these last 2 are acids. If it ends in ane, ene, or ine, that's a way to tell it's organic now. So organic, ane, organic, ene, organic, okay. If it's got a metal, it's ionic, so calcium is a metal, so ionic. Tin, or it has a Roman numeral, it's got to be ionic, so, but tin's a metal, so ionic. And then we got carbon monoxide. Mono is a covalent prefix, so I know that's covalent. And ammonia is one of those special ones we got to memorize, so ammonia is also covalent. Okay. All right, so let's do the ions. So we got to know that calcium is 2+, and permanganate, we can look it up. We got our polyatomic sheet, so we can look that up. So remember, that 4 is not the charge, it's the subscript for the oxygen, and the charge is really just 1-. So we got a 2+ ion, and we got a -1 ion. They're going to be in a 1-to-2 ratio, 1 calcium for 2 permanganates. So I'm going to do CaMnO4 in parentheses, and then outside the parentheses 2, and that would be my final formula, right? We crisscross or swap and drop. But right there, that's my final formula, right, for that one. Okay, let's go to this ionic one. So remember, tin 4, that Roman numeral right there is telling you it's 4 plus. So each tin ion is 4 plus. And sulfide, not a polyatomic. I use my periodic table. It's an oxygen group, so that means it's a 2 minus ion, sulfide. So we got a 4 plus ion, and we got a 2 minus ion. Oops. I'm just going to show you. So we got a 4 plus and a 2 minus. So, you know, if you're strictly just doing it step by step, then we'll swap and drop. So we'll get SN2, S4. But we got to see that a 2 to 4 ratio, remember for ionic compounds, we got to reduce. So 2 to 4 reduces to 1 to 2. So it would really be SNS2 would be the final formula for our compound there. Because remember, for ionic compounds, it's lowest whole number ratio. Okay? So that's ionic. Let's go to covalent. Carbon monoxide, no prefix in front of carbon, so that means 1 carbon. Mono is 1 oxygen, CO. Ammonia, we got to memorize as NH3. That's an easy one to memorize. If you know what ammonium is, take away an H plus and you get neutral NH3, and that's ammonia. Okay. So let's do the acids. So so we have an acid, but we don't have the prefix hydro. So we have to recognize that it's the nitrate ion. IC without hydro goes back to 8, so nitrate. We can look up nitrate and know that that's NO3 with a 1 minus charge, right, on our polyatomic sheet. And if it's 1 minus, that means you only need 1 H plus, so the final formula HNO3. Okay. So this one, no hydro, so dichromate. So we would say, okay, I know the anion is dichromate. So I'm highlighting what the final answer should be. I'm trying to show you a little bit of work, but understand that, you know, this is our final answer. If I ask for the formula, this is what you need to produce. If I, you know, that and that. Okay. So dichromate, and so we can look that up, right? We can look up dichromate. It's Cr2O7, and the overall thing is 2 minus. And because it's an acid, that means we have H in front, but the number of H's depends on the charge of the ion it's attached to. 2 minus means I need 2 H pluses, so it's going to be H2. I got 2, and then a dichromate ion, so Cr2O7, and that would be our dichromic acid. Right there, I'll subscript it, and that would be our formula. Okay, so that just leaves the organic. And so ignore this number. You don't need it. It's just if you wanted to draw the structural formula for the compound, you would need to know where, for this one, it has a double bond, and the 2 is telling you between carbon 2 and carbon 3. This is telling you have a triple bond, and it's between carbon 3 and carbon 4. But that, you know, that number, when coming up with just the formula, number really doesn't mean anything to us. So we'll say hept is 7 carbons, so we'll say C7. And ine, remember, means times 2 minus 2. So we'll do 7 times 2, which is 14, but then we have to subtract 2, so 12. So C7H12 would be the formula for heptine. And then nonane. Non means 9 carbons, so 9. And ane means times 2 plus 2. Times 2 plus 2. So we'll take our number of carbons, 9, we'll multiply by 2, 18, and then we'll add 2. So C9H20 would be our final formula for nonane. And then 2-butene, again, that 2 is just telling me where the double bond is, but for the formula, I don't really care. But is our prefix for 4, so 4 carbons. And ene means times 2, so H8. 4 carbons, 8 hydrogens, times 2. Okay. And so that's, you know, essentially, if you can do this with a periodic table and a list of polyatomic ions, you should be good to go on your nomenclature test. Check the checklist to know all the other questions. Like, you know, you need to know that ionic compounds can end in "ide," "ate," or "ite," you know, depending. You got to know which ions need Roman numerals. You know, you have to know how to spot Ionic compounds know how to spot, organic compounds know how to spot, regular covalent compounds know how to spot, acids. So make sure you review all that, check out the checklist. But essentially, if you can take something like this and answer all the questions there with just a periodic table or a periodic table and a polyatomic ion reference guide, then you're in great shape. Okay. All right. Have a good one.